welcome back to the first PUC 11th standard topic. So we are studying the atomic structure chapter. Now we have to study electronic configurations. Electronic configurations. So to write the electronic configurations of various atoms, we have to consider various rules. The first rule we consider is Aufbau principle. This word Aufbau actually means to build up. To build up. So we are building up the electronic configuration based on the principle called as the Aufbau principle. So according to this Aufbau principle, we write the statement of this Aufbau principle as electrons are filled in the orbitals in an increasing order of their energy levels. Increasing order of their energy levels. So the statement of this Aufbau principle is, we have to build up the electronic configuration, first filling the electrons in the lowest energy orbital and then in the increasing order. But to calculate these energy levels, we are using some rules. Again, in the Aufbau principle there are some rules. The rule 1 states that for any orbital, lower the n value, lower the n plus L value, lower is the energy. Lower is the energy. Say for example, we are having this 1s orbital. For this 1s orbital, this first number is actually indicating this principal quantum number. And for s orbital, L value is 0. Therefore, the n plus L value for this one is 1 plus 0, that is equal to 1. For the 2s orbital, it is n plus L value will be equal to 2 plus 0, that is equal to 2. For the 2p orbital, its value is 2 plus 1, that is equal to 3. For 3s orbital, it is 3 plus 0, that is equal to 3. So for the first 3, we can directly write that it is 1s, 2s and 2p. So 1s having lesser energy than the 2s, lesser energy than the 2p. But when you come to this 2p and 3s, both of them are having the same n plus L value. So to understand the energy level, we have to go for the second rule. So according to rule 2, second rule, for orbitals having same n plus L values, lower the n value, lower is the energy. Lower is the energy. That means between 2p and 3s orbitals, 2p orbital and 3s orbital having the same n plus L values, but for the 2p orbital n value is low. Therefore, comparing to this 3s, 2p orbital is having the lower energy. Similarly, let us continue this with 3p, 3d, 4s. The n plus L values for these orbitals we can calculate as n is 3, L is equal to 1 for the p orbital. For this one it is 3 plus 2, it is 4, it is 5. Here it is 4 plus 0, that is equal to 4. Now after this 3p having the lower n plus L value as compared to 3d, So this is 3p. But between this 3p and 4s, you just observe n value for the 3p is 3, for 4s it is 4. That's why 4s orbital is having higher energy than the 3p orbital. But when you compare this 3d and 4p, 3d and 4s orbital is having the lower n plus L value as compared to 3d. Therefore, we write this as 4s, then 3d. Similarly, we write 4p, 4d, 4f. So it is 4 plus 1 is equal to 5, 4 plus 2 that is equal to 6, 4 plus 2 that is 4 plus 3 that is equal to 7. But again, when you compare this 3d and 4p, having same 5 and 5, but 3d is having lower n value as compared to 4p. That's why we write 3d first. Then comes this 4s, and then comes 4p, 4d, 4f. But when you go for 5s, it is again having the 5 value. N plus L value is 5. So like that, we have to write the increasing order of the energy levels. So it is energy increasing. To understand the same explanation, lower the N plus L value, lower is the energy. And for the orbitals having the lower N plus L values, same N plus L values, lower the N value, lower is the energy. We can represent this by using a diagram. In the diagram, we write this N is equal to 1, 2, 3, 4 like this. I will write this 3s, then lesser than 3p, lesser than 4s, lesser than 3d, lesser than 4p, etc. Now we write n is equal to 1, 2, 3, 4, 5, 6, 7 like this. Then here you write s orbital for this s, p, d and f orbital. In the first orbit there is only one orbital, that is s orbital. In the second orbit there are 2. In the third orbit there are 3, s, p, d. In the fourth one there are 4. 4, 5, 6, 7. I will write this 4. S orbitals, p orbitals, d orbitals and f orbitals. Similarly here 4 we write, 3 we write, 2 we write. N is equal to 7, S and p orbital. The higher we can write, but they are not needed as far as the existing elements at electronic configuration is concerned. Now you consider this 1s. It is having the lower energy as compared to this 2s. Again you consider this 2p, 3s. Then we have 3p, 4s. After that 4s we will get 3d, 4p, 5s. Similarly 4d, 5p, 6s. 4f, 5d, 6p and 7s. So like that we can write the energy levels. In this diagram, when we write the arrow marks, we are starting from this lowest energy, that is n is equal to 1s, n is equal to 1 and s orbital, and energy goes on increasing as we move down. But when we write these arrow marks, we just observe that after 4s we don't write 4p, we write 3d. After 3d we write 4p and 5s, not 4d or 4f. So this diagram is based on these two rules. While writing the electrons in the various orbitals, we should remember the increasing order of the energy levels for these various orbitals. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. After 4p, we have to write 5s and then 4d, 5p, 6s. We will come across all these rules to be followed, or we are following all these rules when we write the electronic configurations. So this is the first one, that is called as the Aufbau principle. According to this Aufbau principle, electrons are filled in the orbitals in an increasing order of their energy levels. So to calculate the energy levels, we are using these two rules. One is lower the n plus L value, lower is the energy. For orbitals having the same n plus L values, we are having lower n value, lower energy. So that is about the Aufbau principle. The second one that we consider is the Pauli's exclusion principle. Pauli's exclusion principle. Exclusion principle. The statement for this Pauli's exclusion principle is no two electrons in an atom have the set of 4 quantum numbers. No two electrons in an atom have the set of 4 quantum numbers same. Quantum numbers same. That means when we have these quantum numbers n, l, m and s, all 4 quantum numbers should not have the same values for 2 electrons in an atom. If n value, l value and m value are same for the 2 electrons, then there must be difference in the s orbit, s value. Say for example, for this helium atom, we write electronic configuration as 1s2. So for the first electron, we write n is equal to 1, l is equal to 0, m is equal to 0. For the first electron, s is equal to plus half, and for the second electron, it is minus half. That means if 3 quantum numbers are same for 2 electrons, there should be at least difference in the spin quantum number. Suppose I write this as 1s orbital. If I write one electron with the upward arrow mark, the other electron should be indicated with lower arrow mark. Means first electron is having plus half spin, second electron is having minus half spin. No two electrons in an atom can have this set of 4 quantum numbers same. So this is about the Pauli's exclusion principle. If 3 quantum numbers have got the same values, at least there should be difference in the fourth quantum number, that is spin quantum number. The third rule, that is called as the Hund's rule of maximum multiplicity. Along with writing the electronic configurations, we shall see in the next video.